Welcome to the Quick Train Modeler video training series. This module will show you how to generate surface models, such as digital elevation models and digital surface models from LAS data. If you've already imported the LAS data to point cloud format within Qt Modeler, you can convert it to a surface under the Edit menu, Convert Model. From the Model Format drop-down, you'll want to select the QTT gridded surface. We'll get into what the Allow Rotated Grid and Grid Sampling options mean in a few minutes. Click the Convert button, and once Qt Modeler is finished processing, you'll notice that you now have a model stored within the QTT surface model format. To generate a surface model directly from an LAS file, click on the Import Model Data button. Under the input format, ensure that LAS is selected, and under the model format, choose the QTT gridded surface. Click on the Import button. Select the LAS file you wish to load, and click Open. This launches the LAS import window. We'll discuss a few of the options in the LAS import window briefly, and then we'll go into detail on some of the other ones later on. For starters, I'm going to leave the processing options set to process individually, because I'm only working with one tile at this time. Under my gridded options, you're going to see there's a grid sampling setting. Think of the grid sampling as the resolution of your dataset. It's nice if you know the post spacing of your LiDAR dataset. In this case, I'm working with a LiDAR dataset that approximately has a 1 meter post spacing, so I'm going to leave the grid sampling setting at 1. There's also an option to allow for a rotated grid. This will generally reduce the size of your surface model, but you'll want to leave it unchecked if you plan on exporting that surface model for use in another software package such as ArcGIS. I'm going to choose to import the intensity data this time. And finally, down below, although I know this data was collected in the UTM coordinate system, the way it was processed meant that this information was not written to the header file, so I'm going to manually define it down below. As a last step, I'm going to click on the Go button, and this will import the LAS data into the surface model. Once the surface model is loaded, I can zoom and pan around, and also turn on and off the intensity information. If you're working with a classified point cloud, Qt Modeler will allow you to generate a surface based on that classification. You can do this within the LAS import window by clicking on the Classification button. Click on Filter using Classification. For this example, I'm going to select to build a surface using Class 2, which corresponds to the ground points. I'm going to click OK. I'm going to uncheck the import intensity, and finally I'm just going to manually specify my coordinate system again. You'll notice that Quick Train Modeler generated a surface for the entire dataset. This even included locations for which there were no LiDAR returns, in this case for spaces under buildings. This may be desirable in some cases. In other cases, you may not like the appearance of the elongated triangles. So let's look at how we can adjust some options in the import settings to change this. Under the Import menu, I'm going to choose Re-import Model Data. This time I'm going to click on the gridding options. And I'm going to set the max distance to real point to a relatively low value of 3 meters. And I'm going to click OK. Just as I did before, I'm going to manually specify the coordinate system and click Go to load the surface with these new settings. With this new model loaded, we can compare the differences between the two models under the Display menu, choosing Show Hide Models. By clicking back and forth between the two models, areas with low point density now result in no data values. Qt Modeler gives you the capability to create a seamless surface across multiple adjacent LAS tiles. I'm selecting adjacent LAS tiles, and instead of process individually, under the processing options I'm going to choose Process as Group. By processing these tiles as a group, we now have a seamless DEM or digital elevation model that doesn't have any noticeable gaps between the two tiles. Within Qt Modeler, we can subtract models from one another. When we combine this with the classification import functionality, it provides us a way to generate normalized digital surface models, or NDSM. Let's take a quick look at how this is done. We're going to import an LAS file again, in this case choosing to import only those ground points. This effectively creates a DEM, or digital elevation model, and so we're going to save this model and call it DEM. Under the import menu, we're going to re-import the model data, only this time excluding the import by classification. Now we've created a DSM, or digital surface model. We can subtract these two models by going to Edit, Subtract Models. We're going to select the DEM and choose Open. Now you can see we have a normalized digital surface model. In this case, we're seeing a surface in which the height of the features is relative to the ground. It's important to note that within Qt Modeler you can display point cloud models and surface models within the same viewer. Here we are flickering back and forth between the DEM surface model we created earlier and the corresponding point cloud created from the LAS file. Surfaces can be exported to common geospatial formats such as GeoTIFF for use within other geospatial software packages such as ArcGIS. Please visit the instructional video section of the Applied Imagery website for a video dedicated to this topic. We hope you enjoyed this video. Please visit the Applied Imagery website for additional Qt Modeler training videos.